Welcome to Global Virtual School. This is your first year chemistry class. I am Dr. Ijaz Banu, and we are on chapter number 2, atomic structure. And the topic for today's discussion is Bohr's atomic model and its application. Students, in this lecture, we will learn about the main points, or you can say the postulates of Bohr's atomic model, and we will calculate the radius of the nth orbit of hydrogen atom. But in this will be continued in our next lectures, and some of the applications will be discussed in next lecture. And after completing 2 days lecture, students, you will be able to use Bohr's atomic model for calculating radii of orbit. Radii is the plural of radius. Radius is the distance of electron which is in orbit towards its central part, that is called the radius. Students, the Bohr's atomic model was suggested by Niels Bohr in 1913, who was English scientist, and he proposed a possible structure of the atom in 1913. According to Niels Bohr, his first postulate told us that electron revolve around the nucleus in definite energy. That definite energy and the circular path on which it is moving is called orbit or shell or energy level. These are the same names: shell, energy level, or orbit. As long as electron is in an energy level, it has a definite energy. If it is in the first orbit, then it has its own definite energy. If it is in the second orbit, then it has its own definite energy for second orbit. So here is the example of this. Is given an atom. You know, this is its nucleus. Nucleus contains, you already know, proton and neutron, while electron revolve around the nucleus. They revolve around the nucleus with a definite energy, and this orbit is called also called shell or energy level. While like this electron is moving in the higher orbit, so if this next electron, they have their own definite energy for second orbit, for second shell, or for second energy levels. And similarly, the electrons that revolve in the third energy level, they have their own definite energy for this orbit, for this shell, and for this energy level. So electrons revolve around the nucleus with a definite energy, and this that is called orbit, shell, or energy level. And Bohr's second postulate is as long as electron remain in a shell or orbit, or you can say energy level, it never gains or loses energy. Let's suppose electron is revolving in the first orbit. It will not lose energy, it will not gain energy. It has a definite energy. If it is revolving in the third orbit, it will not lose energy, it will not gain energy. It has its own definite energy. When it will lose or gain energy, this was explained in third postulate of Bohr's atomic model. Electron lose or gain energy when it jumps from its orbit to any other orbit. It can be moved from its orbit to higher orbit, or it can move from its home orbit to lower orbit. And then it will lose energy when it will move its home orbit to the lower orbit. It will emit the energy and move towards its lower orbit. And when it tends to move towards higher energy level, then it will gain energy, and then it move towards the higher orbit, higher shell, or higher energy level, and their difference will be calculated by E2 minus E1. E1 represent the lower one energy level, or you can say its home energy level, and E2 represent the higher energy level. So this difference tells the how much it will gain or lose the energy. And it's the fourth postulate is about angular momentum of the orbit. You know, electron revolve in a circular path. It has mass and velocity, but it is moving in a circular path, so it has angular momentum. And angular momentum is equal to nh over 2 pi. N stands for orbit number, orbit first, orbit second, third, fourth, and so on. And this is mvr, that is the angular momentum. It is equals to nh over 2 pi, or n can be 1, 2, 3, 4, and up to limiting number it can be. Any unlimited number, that is called infinity number, that is actually called. So angular momentum of orbit, that electron moving in a particular orbit, it has mvr equals to nh over 2 pi. And now the derivation of radius of an orbit of an atom by Niels Bohr. He derived an expression. Expression means he derived an equation. He derived a formula to calculate the radius of nth orbit of hydrogen or some ions like helium ion, lithium ion. Hydrogen is neutral. Helium ion and lithium ion, they are ions. Nth orbit means first orbit, second orbit, or third orbit, or fourth orbit. So by his expression we can calculate the radius of any orbit for hydrogen and some ions like helium ion and lithium ion. Later I will explain what it means to calculate radius of ions. And for that purpose I have this is a simple atom, like this is hydrogen atom, and you know hydrogen has one proton that has a positive charge, and atomic number is on the base of proton number, and that is represented by Z. And this is the electron. Electron has negative charge, it has its own mass, and it is moving with some velocity. So here two forces are affecting: centrifugal force, that tend to keep it away, and a force of attraction by proton towards the electron. So the Coulomb's force of attraction, that is Ze square over 4 pi epsilon r square, that was given by Coulomb's. And this Z is the atomic number. E square means here are two charge of proton, that is positive charge, and charge of electron, that is negative. So both charges, because charge value is the same, so they are collectively known as E square. Pi is constant. Epsilon actually is a vacuum permittivity constant, and it has a constant value, that is 8.84 10 raised to minus 12 coulomb square per joule per meter. And this is the R stands for radius. And now the centrifugal force is mv square over r. M is the mass of electron, and in previous lectures we have calculated the mass, that 9.11 10 raised power minus 31 kilograms. So as two forces are equally affecting, so equating these two equations, this equation 1, that is for Coulomb's force of attraction, and equation 2 for centrifugal force. So equating these two equations like this way, we can find out the expression for radius calculation. Here you can see, and this is for Coulomb's force of attraction, this is centrifugal force, and in this you can see are some common factors, r square and r. So 1 r can be cancelled with this 1 r, and the remaining equation will be like this. Keeping this r on one side and take all the values to the other side. So r here and move mv square with 4 pi epsilon like this. So here you can see radius and velocity, they are inverse proportional to each other. If the radius is low, then it will move with more velocity. If the radius is higher, its velocity will be lower, because these both are inverse proportional to each other. And if you recall the last postulate of Bohr's atomic model, that is about angular momentum, mvr equals to nh over 2 pi. So taking this v here and taking our mass and radius to the other side of the equation, and then taking square on both sides. If you take square on both sides, then we got v square equals to n square h square over 2 square means 4 pi square m square r square. So putting this value of velocity here, we have this form of equation, r equals to z square, this value, and keeping this from the Bohr's postulates. So because as this is in the denominator, it will move this factor, only this factor. Calculate this with me, take out your notebooks and calculate this with me with z square. So we got this equation. Here again you can see we have some common factor in numerator and denominator, so we can cancel them out. 4 will be cancelled with this 4. Here is pi square and here is pi. Pi will be cancelled with this 1 pi. Epsilon is single, mass, and here is mass square, so this mass will cancel with this, n square and h square. And you can also observe r and r square. These are also common in this r, and you can calculate this. So keep this single r one side and take all these values to the other side of the equation, and you got this final expression or formula for calculating the radius of hydrogen, helium ion and lithium ion. So finally we have this equation. In this you can see epsilon, it is constant, Planck's constant 6.62, 6 to 10 is 1 minus 34 joule second. Charge is constant, pi constant value, mass of electron is constant. So only two things are variable, z atomic number and n, this is the orbit number. For hydrogen, if you are calculating for hydrogen, you have to keep this 1. For hydrogen, you have to keep the value of z1. For helium ion, helium's atomic number is 2. If you want to calculate for helium, then you have to write 2 here. If you want to calculate for lithium, that is plus 2 charge, and lithium's atomic number is 3. In that case, if you are calculating for lithium, then you have to write 3 for this atomic number, and n is variable. If you want to calculate for first orbit, then it will be here you will write 1 square. If you want to calculate for second orbit, you have to write 2 square, and so on. While all others have constant values, I will just tell you the exact values, and you have to memorize the constant values. So this was our radius. Here I will just calculate for hydrogen atoms. I already explained you for helium and lithium. You can calculate for helium and lithium ions. This z, so this was 1. So 1 mean 1. So this is the radius to calculate. This is the expression, or you can say formula, or you can say this is the equation to calculate the radius of the nth orbit. So now keep all the, I already told you these are constants and this is variable. Keep the constant aside and variable on one side, and you know this expression, because this is a combination of lot of constants, so we can also this give another name, a naught. This a naught, this is the combination of constants. So and keeping putting the values of Planck's constant h, epsilon, pi, m, e square, we can find out its value. As you know, Planck's constant 6.62 10⁻³ 34 joule second. Epsilon, it's coulomb square per joule per meter, and pi 3.14, no units. Charge units, you know, coulombs, and the mass, you know, this is the mass of electron in kilograms. So putting all these values here, you can find its numerical value, that is 0.529 10⁻⁻10 meter, and you know 10⁻⁻10 meter is equals to 1 angstrom, a naught. This is represented by a naught. So if we put just 0.529 instead of this, then this equation will be like 0.529 angstrom and this one n square. Now this is very easy to calculate the orbit first, radius of first orbit second. If you want to calculate the radius of first orbit, you have to take the square of 1, and its answer obviously a square is equal to 1 square is equal to 1, and this will multiply and give answer 0.529 angstrom. Similarly, you can calculate for second orbit. 2 square means 4, so you have to calculate multiply 4 with 0.529, and in this case you find its value, it's almost 2.116 angstrom. Similarly, you can calculate the radius of the third orbit. 3 square, that is 9, so 9 will multiply with this. Even you can find the difference of the radius, like r2 minus r1, r3 minus r2, r4 minus r3, and even you can give it either it's increasing radius gap or decreasing. This is for you to solve. Calculate the radius 2 and 1, 3 and 4, 3 and 2, 4 and 3, and then compare it if the distance gap is increasing or decreasing. And this question can be asked in the exam as a short response question, and overall the calculation of radius can be asked for a long response question. So this is the example we have just in previous slide, immediately previous slide we have calculated all the values. Just A naught is the combination of constants, and putting the values of constant you got the value of A naught, that is 0.529 angstrom. These are the some short response questions from your book exercise. And Bohr's equation that is given of nth orbit. This is automatically, there is no atomic number, so it means this is for hydrogen atom. When electron is moves from n1 to n2, obviously you know this all has a value 0.529, just we have calculated in previous slides. N1, first write n square, 1 square, then 2 square, and then calculate r2 minus r1. That will give you the answer. What is the distance traveled by the electron when it goes from n2? So in this case you have to calculate first r8 and r3, find the difference and you will find out the answer. Here is the question for you, for your understanding. If you have understand the calculation and expression of the radius, then you can easily find out. Let I explain you for you. Calculate radius of first orbit of helium, and you know these are constant, and it has value 0.529 angstrom, and n I told you for first orbit, so take square of 1. And you know for helium its atomic number is 2, then you have to divide it by 2. You can easily find the answer. Similarly, if you can ask for lithium, then you will keep 3, which orbit, first, second, third, accordingly you have to put the value. Is that not easy? It's very easy. Students, this I am asking you from, what is common in hydrogen, helium and lithium? What is common in them? Why was calculated for hydrogen, helium ion and lithium ion? Yes, these all are one electron system, mono electron system. How? Hydrogen's atomic number is 1, so 1 proton, 1 electron, so it has 1 electron. Helium's atomic number is 2 proton. I'm talking for a neutral helium, 2 proton and 2 electron, but now it is helium plus 1, so 1 electron is taken away, so remaining electron is 1. Lithium's atomic number is 3 for a neutral atom, but it has 2 positive, so because 2 electrons are taken away and it got 2 positive and remaining electrons are 1. So these helium ion, hydrogen neutral and lithium ion, these are mono electron system, or you can say one electron system. So Bohr's postulate is basically calculating the radius for one electron system. Here is the question again. conceptual question. Hydrogen atom and helium I are monoelectron system. Both have single electron, but the size of helium is smaller than hydrogen. Can you calculate this? Of course, you can prove them by calculating and also explain by in this way. Like we have hydrogen, this one. I already told you atomic number 1, so 1 proton and 1 electron. And helium, the atomic number is 2, so 2 proton, and he in this case asking about plus 1, and this is neutral, because if one electron is taken out and it got a positive charge and remaining electron is 1, and here you can see the one positive is attracting one negative, and in this case two positive charges are attracting one, so this radius is reduced, so its size reduces. Similarly, you can see lithium 2 plus, it has 3 positive charge and it has 1 electron, so 3 positive are attracting 1, so size will be gradually reduced for helium and then lithium. In this way, hydrogen, helium 2 plus, 1 plus, and lithium 2 plus. And even you calculate for radius for hydrogen, radius for first orbit, you can for helium plus 1 I and for radius of lithium 2 plus I, and you can prove which one has smaller radius. Bohr's postulate. Today we have understand the Bohr's postulates, and we also derive the expression to calculate the radius of monoelectron system. And our next topic will be the continuity of the Bohr's atomic model. In that case, we will calculate the energy, and after energy, we will calculate the difference in energy of the orbits, wave number, and frequency of the orbits. And so this was all about the Bohr's atomic model and one of its applications.